yesterday we started section 2.4, quadratic functions. We did page 1. So let's flip over to page 2. So we have two ways of expressing a quadratic function. There's the ax squared plus bx plus c form. Which is the form you're familiar with in applying the quadratic formula to. Okay? And then there's the alternative, a times x minus h squared, right, plus k. Okay? And if you think about it, this form here, right, we just start with the basic squaring function, y equals x squared. All this is a transformation on y equals x squared, right? First you vertically scale this by a. So you have ax squared. Then you shift it horizontally, h units. So you have a times x minus h squared, right? So this is vertical scaling. And this is a horizontal shift. And then when we add k, we're doing a vertical shift, right? So we're taking this basic graph, ax y equals x squared. And we're doing a vertical scaling. Then we're doing a horizontal shift. The last one we add k, we're doing a vertical shift. Okay? All these things you're familiar with from the previous section. Now this vertical scaling A may also include a reflection across the x-axis that A is negative, right? So this could be both a vertical scaling and a reflection across the x-axis if A is negative. Okay? All right, so we're going to express a quadratic function in this form here by completing the square. So if we have x squared plus bx, what number do we have to add to that in order to create a perfect square, right? A perfect trinomial, which can be written as a perfect square. Well, you know from the section on circles, right? In order to write the equation of circle in standard form, right, we took the number in front of the x, divided by 2, and squared it. That's what we added to both sides of the equation. So we do the same thing here. Take the number in front of the x, divide it by 2, and square it. You have, ends up being b squared over 4. So that's what we add. Put in the blank there, that's what we add to x squared bx. And when we do that, now we have a perfect trinomial, and it factors into x plus b over 2 squared. Okay. And then we're going to be doing this, right? We're going to be doing this basic idea, right? And rewriting a quadratic function, going from ax squared plus bx plus c form to the other form. Okay? All right. So where it says in general, we have ax squared plus bx plus c. We're going to show you how to complete the square, okay, on that. So the first thing we're going to do is factor out an a in the first two terms. So we have a times the quantity x squared plus b over a x. Okay? So I factored out an a from this sum of the first two terms. And then you can see if I distribute the a back inside the parentheses, a times x squared is ax squared, and a times b over a, the a's cancel, and I'm just left with bx. Okay. Now, we're gonna add 0 to this sum inside the parentheses by adding and subtracting the same number, right? You know 5 minus 5 is 0, 10 minus 10 is 0, right? So we just got to add and subtract the same number. And then we have the plus c out here on the end. Okay. Well, the number we're going to add and subtract, right, is the number that we need to complete the square here. So we're going to create a perfect trinomial. Right? We're going to take this number in front of the x, divide it by 2, and then square it. Well, you know that division by 2 and multiplication by 1/2 are the same thing, right? So dividing b over a divided by 2 is the same as 1/2 times b over a, right? Division by 2 and multiplication by 1/2 are the same thing. Right? And now we got to square this. So what we're going to add and subtract inside parentheses is b over 2a squared, which is equal to b squared over 4a squared. Okay? So that's what goes in the blanks. We add b squared over 4a squared, and we subtract b squared over 4a squared. Okay?
Can you explain that again, like why you did all that?
This here?
Mm-hmm.
Because we're going to create a perfect trinomial with these first three terms that can be factored as a perfect square. Okay? That's what we did over here. We had x squared plus, there's a 1 in front of x squared here, right? A is equal to 1. So to create a perfect trinomial, we took the number from the x, divided by 2, and squared it. And when we added that number to x squared plus bx, it then factored into a perfect square. X plus b over 2 quantity squared. Okay? That's what we're trying to do here. Okay? All right. So now, I'm gonna, if I distribute the a inside parentheses, we're gonna multiply all 4 terms by a, right? So we're going to distribute the a inside the parentheses to these first 3, or apply a to the first 3 terms. We're gonna split this up, and then we're gonna subtract and multiply a times this 4th term. Okay? So we're going to split this up parentheses into the first 3 terms minus the last term. Okay? And so when we do that, we have a times in parentheses the first 3 terms okay? And then we're going to subtract and multiply a by the 4th term. Okay? So instead of multiplying all 4 terms by a, right, we're just multiplying a by the first 3 terms, and then subtracting and multiplying a by the 4th. So minus a times b squared over 4a squared, and then plus c, okay? Are you with me? Do you follow me how I did that, go from this step to this step? Okay. Now, is this in parentheses a perfect trinomial? Yes. So it can be factored into a perfect square, just like we did with the standard form of the equation of a circle. So this is equal to a, and it factors into x plus b over 2a quantity squared. Okay. How do I know it's b over 2a? Because that's what's inside parentheses. Okay. And so we had to take the number in front of the x, divide it by 2, and square it, create a perfect square. So this number in parentheses is what goes down here. And then this part here, minus a times b squared over 4a squared plus c. I'm going to switch the order, put the c first. Actually, when you simplify this, find a common denominator, and simplify this, you end up with 4ac minus b squared over 4a. That's what minus this plus c simplifies to when you find a common denominator. Okay? Now you should verify that. Try to verify that on your own. And if you can't, right, come see me. I'll show you. Okay? All right. So any questions on this? Okay. So the new, so in this form over here, right? So we went from this form to this form. So when you compare this to a times x minus h squared plus k, okay? What do you see? H is equal to negative b over 2a, and k is equal to the 4ac minus b squared over 4a. That is consistent, right? Remember the vertex is at HK. Well, that's consistent with when we were working problems, when we were finding the vertex of the quadratic function in form ax squared plus bx plus c. The x coordinate, right, was that x equals minus b over 2a. And the y coordinate was that y equals f of minus b over 2a. And f of minus b over 2a, when you plug in for x up here, ends up equal 4ac minus b squared over 4a. Okay? So we just proved that when you're given a quadratic function in this form, the x coordinate of the vertex is minus b over 2a. Okay? That's what this is, the x coordinate of the vertex. And the y coordinate is f of minus b over 2a. And when you plug that into x over here, you end up with 4ac minus b squared over 4a, which is the y coordinate for the vertex over here. Okay? So yesterday, when we were using minus b over 2a for the x coordinate and f of minus b over 2a for the y coordinate, where did that come from? It's not magic, okay? It came from completing the square. Okay. All right. So let's do something a little more interesting and actually apply what we've learned here. So let's take a look at example 3. Use the completion of squares to express the quadratic function in standard form. State whether the function's graph opens upwards or downwards. Find the vertex and sketch the graph of the given function. Okay. So in A we have f of x is equal to x squared plus 2x plus 5. Okay. Now in yesterday's lecture we know how to find the vertex, right? But today we're going to do it differently. We're going to do it by completing the square. Okay? And you notice there's the invisible 1 plus 1 in front of x squared, right? So A is equal to 1 in this case. B is equal to 2. C is equal to 5. So to complete the square, we got to add 0 to the right-hand side, right? By adding a number and subtracting that number. Okay? So we're going to create a perfect trinomial. It's equal to a perfect square. So how do we find the number that we add? Take the number in front of the x, divide it by 2, and then square it. 2 divided by 2 is 1. 1 squared is 1. So we add and subtract 1. And put 1 in the blanks. We're just adding 0, right? 1 minus 1 is 0. Well, now, this x squared plus 2x plus 1 is a perfect trinomial. Factors into a perfect square. So this is equal to x squared plus 2x plus 1 factors into x plus 1 squared, and minus 1 plus 5 is 4. Okay. So this is our original quadratic function in standard form. Okay. State whether the function's graph opens upwards or downwards. Right? Remember, parabola is either opens up or opens down. What does this one do?
Opens up.
Opens up because
The function's not
A is positive or negative. If positive, it opens up, right? So A is greater than 0. So the graph opens up. Last time I checked, 1 is greater than 0, right? Where's the vertex? Well, what's h equal to in this case? Negative 1. Just like with putting a circle in standard form, you got to change the sign of the number. So h is equal to negative 1. K, you don't change the sign, you leave it alone. K is equal to 4. Okay. So the vertex is at the point HK. Where h is minus 1 and k is 4. Okay. Now you got to sketch the graph of the given function. Do you have enough information to give a rough sketch? Yes. So here's the coordinate plane, x and y axis, and here's -1 on the x-axis, 4 on the y-axis. And so here's the vertex at the point -1, 4. And we know that the graph opens up. So that's roughly what the graph looks like. And I think we're done. We've answered all the questions, have we not? It said it opens up. We found the vertex, and we sketched the graph. Okay. The crude sketch. Okay. What's the domain of all quadratic functions? Yeah. Okay. But the range is limited, right? What's the range on this one? It's the y coordinates, right? What's the lowest y coordinate? What's the largest y coordinate? So the range is 4 to infinity. Okay. All right. What's the axis of symmetry? X equals -1. It's a vertical line, right? So you got to write it as an equation of a vertical line. X equals -1. Okay. All right. In B, we have f of x is equal to 2x squared plus 12x plus 15. Right? So A is equal to 2 in this problem. B is equal to 12. And C is equal to 15. So what's the first thing we got to do? A isn't equal to 1 in this case. What's the first thing we got to do? Got to factor out the 2, right? From the first 2 terms. Got to factor out a 2. So when we factor out 2, we have 2 times x squared plus 6x, right? But inside that parentheses, we got to add 0. Add a number and subtract that number, right? And then you can't forget the plus 15 out here on the end. Well, what's the number that we add and subtract to create a perfect trinomial? Take the number in front of the x, divide it by 2, and then square it. So 6 divided by 2 is 3. 3 squared is 9. So we have f of x is equal to 2 times x squared plus 6x plus 9 minus 9 plus 15. Are you with me so far? And now we're going to split up what's inside the parentheses. Take 2 times that perfect trinomial, and then 2 times, and then minus 2 times 9. So we have, this is equal to 2 times x squared plus 6x plus 9. Okay? And then minus 2 times 9 plus 15. Okay? So we're multiplying, right? We're doing the form of the distributive property. 2 times this perfect trinomial minus 2 times 9. This perfect trinomial factors. What does it factor to? Squared, right? So this is equal to 2 times x plus 3 squared. And now this last part is just arithmetic, right? Minus 2 times 9 is negative 18, and negative 18 plus 15 is minus 3. Okay? So we're done as far as completing the square part. Right, we use the completion of squares to express the quadratic function in standard form. That's standard form. Okay. State whether the function's graph opens up or opens down. Opens up or opens down. Up, right? So A, right, is equal to 2, which is greater than 0. So the graph opens up. Okay. The vertex, what's H equal to in this case? And what's K equal to? So where's the vertex? There you go. Okay. And now we can graph, do a crude sketch. So here is my coordinate plane. X-axis, Y-axis. And so here's roughly -3 in my coordinate plane. All right, here's -3 on the X-axis, and there's -3 on the Y-axis, roughly. So the vertex, right, is here at the point -3, -3. And the graph opens up. And again, right, this isn't going to be perfectly symmetric like you would get with graphing software. Okay? But that's roughly what the graph looks like. Okay. All right. So going back to our basic equation, quadratic equation, y equals x squared. Okay. Did our basic quadratic equation get compressed or stretched? And going from there, yeah, it got stretched, right? Because vertical scaling is +2, right, on the x squared. So that's, it got stretched. Okay, very good. Okay. All right, any questions on that? Okay. So flip over your page. And we'll talk about the quadratic formula, which you're probably familiar with from your high school algebra days. So here, right, what's the formula? X is equal to -b plus or minus the square root b squared minus 4 times a times c, right? And that's all divided by 2a. And remember, division does not undo addition and subtraction, right? So technically, you're dividing -b by 2a, and you're dividing the square root by 2a, okay? The discriminant of the quadratic equation, right, which is this, the radicand under the square root, okay, determines the number of real solutions of the equation. So, if the discriminant b squared minus 4 times a times c is positive, greater than 0, there are 2 distinct solutions. If b squared minus 4 times a times c is equal to 0, There's only one. Okay. And I should point out, these are two distinct real solutions. Okay. And in 3, if the discriminant is negative, well, you know the square root of a negative number is not real, right? It's imaginary. Okay. Then there are no real solutions. Only imaginary. Okay. All right, any questions on that? Okay. So in example 4, right, we have 2 quadratic equations. In the we have 2 quadratic equations. Each one, right, is just in the variable x. So we can use the quadratic formula to find the solution to each of those quadratic equations in the variable x. Okay. All right. Determine the equation, or excuse me, use the equation to solve the equation. First one, x squared minus 8x plus 13 is equal to 0, right? There's an equation in one variable, quadratic equation in one variable. So a, in this case, is equal to 1, b is equal to negative 8, c is equal to 13. So we just plug into the quadratic formula, right? The negative of minus b in this case, right, is the negative of negative 8 plus or minus the square root of b squared. Well, b squared in this case is negative 8 squared. We have minus 4 times a, which is 1, times c, which is 13. And all that is divided by 2 times a, which is 2 times 1 in this case. Well, the negative of negative 8 is plus 8. And the discriminant, minus 8 squared is 60. Now this is PEMDAS, right? You all know PEMDAS, right? Exponentiation, then multiplication, then the subtraction. So minus 8 squared is 64. And then when we do the multiplication, 4 times 1 times 13 is 52. The denominator 2 times 1 is 2. So the discriminant, right, is simplifying to 64 minus 52. 64 minus 52 is 12. So we have 8 plus or minus the square root of 12 divided by 2. So remember, division does not do addition and subtraction. So this is equal to 8 divided by 2 plus or minus square root of 12 divided by 2. The square root of 12 reduce? What does it reduce to? To root 3. Do you have to reduce radicals in mathematics? Yeah. Okay. So x is equal to 4 plus or minus the square root of dadgummit, square root of 3. So how many solutions are there? 2, right? You use the plus sign and then the minus sign, right? So 4 plus square root of 3 is 1. 4 minus the square root of 3 is the other, right? Just to remind you of that. X, use the plus sign, and use the minus sign. Okay. All right. Are you with me? Ready to take the quiz? Stop for the day? Huh?
Yeah.
Friday? Be sure to have some fun this weekend if you worked hard all week. If you didn't work hard all week, you gotta stay home and do your math. Okay?